Okay, let's start. Hello everyone, my name is Zvonko. I am from University of Ljubljana. I'm the colleague of Professor Jurič. He cannot be here today. He's sending his regards. What I'm gonna speak about today is KumuluzEE microservice framework for Java EE microservices. I will also demonstrate how to deploy KumuluzEE microservices to the Kubernetes cluster, and I prepared short demo for this. So let's do a quick overview of the topics that I would like to cover today. First of all, I would like to explain some, let's say, general information about microservices. Why are they so important in terms of scalability? Why do we need concepts such as health checking, monitoring, configuration, logging, fault tolerance, and many other concepts of microservices to basically build resilient and scalable applications. That will be the first part. Then in the second part, we will go and explain a little bit some information about Kubernetes. And also, we're going to look at it from the perspective of microservice framework. Okay, so Kubernetes provides this many utilities that you can use, such as self-healing, auto-scaling, rolling updates, and so on. But it's very important that the framework that you use to develop your microservices also provides and enables actually the underlying technology to obtain information that it needs to scale applications, to perform self-healing and stuff like this. Then I will explain I will give you some information about KumuluzEE microservice framework. And then gradually we will go to demo and demonstrate how to deploy application to the Kubernetes cluster. Mostly we will focus on self-healing and auto-scaling of microservices. Before we continue, I would just give you a couple of questions. Do any of you use microservices? Okay, very few. Maybe did any of you heard before about KumuluzEE? Oh, okay. Let's continue. So scalability. Now, microservices are basically developed with scalability in mind. Okay, today's architecture and approaches that we take to implement applications basically are focused on scalability. This means that we want application to be small so we can start it up very quickly, okay? And this is the most important thing with scalability. So if we compare microservice with let's say, a traditional infrastructure where we deploy application, monolith application to the application server, so the scalability for traditional infrastructure would mean that we need to, let's say, do the copy of the whole virtual machine and start it up. Okay, so the startup time in this case can be quite long. But with microservices, because they are small, they are packaged into small Uber jars that are then combined with containers such as Docker, you can start them up actually in the matter of a few seconds. And that actually allows you, that gives you a great elasticity. Okay, then we have concept of health checking. So the microservices should provide endpoints that allow other microservices that integrate with this microservice to check if the microservice is healthy, if it's able to serve the data, and so on. And not only that, we need health checking for the underlying infrastructure, such as Kubernetes. Okay, so Kubernetes is basically able to monitor applications if they're healthy, basically. And in case that's not the case, Kubernetes is basically able to take action, so to try to re-heal this microservice. I will show this later on the example. Then we have monitoring and metering, also very important. Now you have application that is comprised of multiple microservices, and you want to perform monitoring through some central monitoring aggregation service, such as Kibana, for instance. And microservices should expose endpoints that give you detailed deep insight into application behavior. Also important is configuration. So when you have multiple microservices, it's hard to configure each microservice and take care of them separately. But what you want to have is central configuration service, let's say, that you can use to configure microservices. We have so these concepts are basically need to be covered with the microservice frameworks. Okay, so and in this case, in the case of KumuluzEE, basically you have all these components which you can use to provide this concept, to cover this concept. Okay, so Kubernetes is today probably one of the most commonly used runtime platforms for containerized applications. It provides different utilities such as self-healing, horizontal scaling, service discovery, automated rollouts, and rollbacks. So when you update, provide, or deploy a new version of your microservice, Kubernetes will make sure that it will deploy a new version in a rolling update way. So if you have multiple instances of the microservice, will update one by one. Okay, so basically you have no downtime when you're updating your application. And also, if something happens, so if the new version is not working, the Kubernetes will roll back to the previous version. Okay, so from the perspective of KumuluzEE framework today, we will demonstrate self-healing. So, as I said before, Kubernetes is able to monitor health check API endpoint and restart the container when it detects it failed. We will also gonna show automatic scaling. Now, out of the box, Kubernetes currently supports scaling based on CPU and memory usage, but you can also implement scaling based on some custom metrics. Now, in this case, you need to have framework that enables you to expose your custom metrics, and what you could do is implement your custom scaling algorithm. Okay, some information about KumuluzEE microservice framework. It's open source framework, and it's supporting most of the standard Java EE APIs. It is microprofile 1.2 compliant, and we're currently working on compliance with 1.3 version. What is microprofile? Basically, it's a specification that defines what the optimal microservice framework should provide. Now, our framework was tested against some other microservice frameworks, and it turned out that we are very good because we are able to provide very small jars. And also we have very good, very small startup time. And basically, why is this possible for our framework? It's because we're building our framework from the ground up. So we only include in the application what we actually need for execution. Now, the other frameworks, such as, I don't know, Swarm and Liberty, are a bit different because they go the other way around. They take the application server and then they decompose it. So this way you still have some stuff in there you don't maybe need or want. KumuluzEE provides different extensions and components, such as component for logging, managing logs, metrics, health, event streaming, config, service discovery, fault tolerance, and many others, which I will demonstrate. Now for the demo, I prepared 2 microservices. First one is called orders microservice and customers microservice. So the customer microservice integrates with the orders microservice, but what I would like to expose at this point is that orders microservice basically will use service discovery, okay, which I will demonstrate. So when the microservice is started, it will automatically register itself to the service registry. Now in our case, this will be etcd cluster. What this means is that when other microservice wants to use these orders microservice, it will use service discovery. So with microservices, you no longer integrate with other services by providing the URL, but you use service discovery or service registry. So the client application will actually ask, okay, I want to integrate with orders microservice with this version of microservice, and please give me the URL to one of the instances, okay? So the orders microservice can actually run, there can be multiple instances of this microservice. And the service discovery will actually handle the load balancing, okay? It will give URL to one of the instances, to one instance of this microservice. Then we have configuration of these microservices that is done through the KumuluzEE config component, which basically allows us to provide configuration for the microservices via environment properties, via config file, or via config cluster. etcd or console is the other one. And of course, as every microservice should, it exposes health and metrics endpoints. Then we have customers microservice. It integrates with orders microservice. It will perform service discovery, and also it uses KumuluzEE config to configure data source, config cluster, discovery, metrics, health. What is another important thing here with customers microservices, when it integrates with the orders microservices, it will use fault tolerance to handle failures in case something goes wrong with communication, for instance. So in microservices, you actually expect that failures will occur. Okay, so you need to have mechanisms such as fault tolerance that will be able to stop failures, so the failures will not propagate to other microservices, okay? Because if you have a chain of microservices that are integrated, if one fails in this chain, you don't want that all the rest that are integrating with some microservices to also fail. And the fault tolerance is the mechanism that allows you this. Okay, now let's go to demo and show how to enable self-healing and how to do the auto-scaling of the KumuluzEE microservice. Okay, now I will switch to my development environment, and we will go step by step through the code. Okay, so this is my project. Let me just close these windows. Okay, this is my project. I have Maven module that is implementing customers microservice, Maven module for orders microservice. Then I also have web UI and folder where I store all the configurations that I need to deploy these microservices to the Kubernetes cluster. Now, both microservices are developed in pretty standard way. We have REST API, we have business logic implemented in CDI beans, and we have persistence module that basically handles the entities and database stuff. Okay. We're gonna start with orders microservice. And the first thing I would like to show you how the service registration is done. So how KumuluzEE Discovery will register the microservice when it will be started up to the service registry. Okay, so what do I need to enable this? First, I need to include the dependency, KumuluzEE Discovery, and I need to provide which implementation of Discovery. So in this case, we have etcd cluster. We also support some other. Okay, this is the first step that we need to do. Then, from the implementation perspective, what I need to do is on the JAX-RS application class, I use this annotation, register service. Okay, this is from the implementation perspective is all what I need to do. Register service, and I need to provide some configuration. Okay, what I need to provide is the name of the service, then the environment in which this microservice is running, and the version of the microservice. How can I do this? Is via configuration file. Okay, so this is this information, name of the microservice, environment, which in our case will be development, and the version. And one more thing is basically discovery configuration. I need to tell my microservice to which service registry the microservice needs to register. I basically just add the URL. Okay. This is configuration of service registry. And this is all we need. When we will start this application, it will add the instance to the registry. Okay, then let's just have a look at the other configuration that is done in this file. We have configuration of the data source. I provide information for the database, username, and so on. Then I have configuration for metrics. Metrics component of KumuluzEE allows you to expose metrics of Java virtual machine, information about heap and so on by default. And then you can also implement monitoring or metering of the calls to some URL pattern. And you can also implement your own matrix as you wish. And finally, we have configuration for health checking. Now, in this microservice, we have two health checks: data source health check and disk space health check. Okay, these are health checks that are provided by KumuluzEE framework by default. We also have support for many others, like etcd health check and others. Okay, this is regarding the configuration. If I go back to POM.xml, how do I enable metrics and health? Basically, what I need to do is just include these dependencies. Okay, so this is orders microservice. Before I deploy this microservice, I would just like to show you the configuration of deployments to the Kubernetes. What I have here is configuration for database, for web UI, and for etcd, which is a service registry that I will use, and configuration for my two microservices. I will not go into details of these, I pre-deployed some of them, which I'm going to show you. I'm going to connect to my cluster. Pods. So just you can see. Sorry. Okay, what I have deployed here, I have pods for etcd service discovery cluster, databases, so each microservice has its own database, and web UI. Okay, this is already deployed, and now we are going to deploy orders microservice, and then later on, customers microservice. Okay, so how do I do that? I'm going to use this order deployment YAML file, which contains the following configuration. Now, if you listened before the lecture, the session about Kubernetes, you're already familiar with some of this stuff. What we have here is one container that uses this image, which basically packages my jar file of the orders microservice, and then we use environment properties from config map, which is named in the following row. So we're using this config map, and these are the properties that are defined in this config map. Okay, so URL to etcd to service registry, URL to database, and some information for health checking. Okay, then important part of my deployment here is liveness probe. Now, I explained before that we defined and configured health check endpoint on orders microservice. Okay, this will expose the health endpoint, but I also need to tell Kubernetes to monitor this health endpoint. How do I do this? I define liveness probe, and I tell Kubernetes to perform HTTP GET request to my container on the path/health. Okay? And it will periodically check this endpoint every 5 seconds, and it will wait 30 seconds when I spin up this microservice. Okay? And finally, I also have resources. I've limited the CPU to 0.3 virtual core, and I need this later on for the automatic scaling. Okay, so let me deploy this microservice. All I need to do is provide the configuration file, deployment YAML. Okay. Okay. Now, if I check the pods, I can now see the order deployment pod. It's running for 48 seconds. Okay? Let us just check if it's really running. And for this, I will go here to my web browser. And here I have the web UI, which basically is already connected to the orders microservice, or more precisely to the health endpoint of the microservice. Okay, so this icon here, green, it's showing me the status of my health status of my microservice. But to get more information about health of this microservice, I actually I can call the endpoint. Okay, so this is orders microservice and the result of /health endpoint. the status of this microservice is up. All 3 health checks are saying up, everything is okay. Okay, one more thing that I would like to show you. I said before that service will register itself when it will be started. Okay, so I have here etcd browser that is connected to the service registry, and I can see if there are any instances registered. So if I click here, I should get the list of instances. Okay, and here I have the data. I have one entry because only one part of my microservice is running, and I have data that I need to connect to this microservice. So container URL, which is basically URL that I will use inside the Kubernetes cluster, and the URL, which is basically URL that I can use to connect to this microservice from the outside of the Kubernetes cluster. Okay, so now I will click on infect order service, and the status will go down. I will refresh here the health status. Now it says down. Okay. Let me switch to Kubernetes and check the status of the pod. Now, if you look at it closely, you can see that container was restarted. Okay, and this is how Kubernetes actually performs the self-healing of the microservice. Okay, I have one more thing to show. I'm running out of time, so I will do this quickly. I will also deploy a customer microservice. And I will create horizontal pod autoscaler for orders deployment, okay? Which I do with kubectl autoscale deployment, order deployment, and I need to provide sorry, just a second. I need to provide the limits that I will use to scale my deployment. Okay, so CPU 50. Minimum number of pods for my microservice is 1, and it will scale up max 4 pods, let's say. Okay, so the horizontal pod autoscaler is now created. Sorry, I can check it. It will take a couple of seconds to get the data from the pod. And once it will get the data, it will start monitoring. Okay, now just to quickly send some request that will overload this microservice. Basically, it will start calculating the Fibonacci sequence, and the Kubernetes will detect that it's getting overloaded. It will take some moments, a couple of seconds, that is overloaded, and it will start. It will start scaling. Okay, I will have to finish now. I am inviting you to check out the web page of our framework. You can go to ee.kumuluz.com. You can check what our framework is supporting, which components. It's quite a lot of them: config, discovery, security, fault tolerance, gRPC, and so on. You also have generator. You can click which components you would like to try out, and the generator will generate the sample project for you. Okay. You also can visit our blog, and if you're interested, you can also join to the community of the developers. Okay. Let me just check the horizontal path autoscaler. Sometimes it needs couple of minutes, so it will actually scale. So if we would wait for a couple more, for 1 more minute, you would be able to see that multiple replicas are started for the orders microservice. Okay. Do you have any questions? With Gradle? Yeah, no, not yet. Not yet.
But he can always chip in and create his own support for Gradle.
Yes. Yes. Open source, yes. Okay, I will stop now. Thank you.